In this video, we're going to be working through another application of integrals, and that's finding the areas between curves. So let me draw a particular picture for you to sort of state the kind of problem that we're going to be solving. So let this be the x and this be the y as usual. So let's draw a couple curves here. So let's assume we have a line that's going out of here. Let's assume we have another curve here. So like a parabola. And let's assume we have another parabola that sort of sweeps in this way. Actually, I don't like that parabola. Suppose we have that. So we have these three curves in space, and they all intersect at three obvious points. Clearly, green and red is going to intersect at some point up here, but we're not actually going to be interested in that. So the goal of this video is to find the area of this region bounded by these three curves. So it's almost like a curvy triangle looking shape. So how can we find that integral or that area? Alright, so let's give these curves some names here. Let's call this line y is equal to 2x minus 1. Let's call this green curve y is equal to x squared minus 12x plus 40. And let's call this other parabola y is equal to x squared. So the first thing that we need to find, so step 1, is find the intersection points. So I'm going to call this point A, I'm going to call this point B, and I'm going to call this point C. So A is the intersection of what two curves? So this is going to be the intersection of 2x minus 1, the red curve, and the pink curve. So that's going to be y is equal to x squared. B is going to be the intersection of pink and green. So that's going to be y is equal to x squared, and y is equal to x squared minus 12x plus 40. And C is going to be the intersection of green and red. So x squared minus 12x plus 40, and the line 2x minus 1. So let's find out the x coordinates. So you only need the x coordinates for this. So let's solve the first equation, so A. So when is 2x minus 1 equal to x squared? So we can isolate these things. So x squared minus 2x plus 1 must be equal to 0. We can factor that. So that's going to be x minus 1 times x minus 1 squared. So that means x must be equal to 1. B. So when is x squared equal to x squared minus 12x plus 40? We can subtract both sides by x squared, so 0 is equal to negative 12x plus 40. So if that's the case, then that means x is going to be equal to positive 40 divided by 12, which is 20 over 6, which is 10 divided by 3. So that means x is equal to 10 over 3. And C. So when is x squared minus 12x plus 40 equal to 2x minus 1? So that means x squared minus 14x plus 41 must be equal to 0. We can use quadratic equation for this, and there's going to be two values for this, right? So we have a line and we have a parabola. So remember our other curve sweeps down here, and this is the area of interest, right? So there's going to be two solutions to this equation. The first solution is going to be the x value there. I'm going to call it xl. And there's going to be another solution over here, which I'm going to call xr. Notice that xl is the only point that I'm interested in, right? And remember, for the quadratic equation, we have x is equal to negative b plus or minus the square root of the discriminant, all divided by 2a. So that means if we choose the left one, So that means XL, the point of interest, is going to be negative b plus or minus the minus only the square root of the discriminant all over 2a. So that means x is equal to negative b plus or minus the square root, keep on saying plus or minus, minus 14 squared minus 4 times a times c, all over 2a. So that means x must be equal to 14 minus, so 14 squared minus 4 times 41, that's going to be 32, all over 2, which is 14 minus the square root of 16 times 2 over 2, or 14 minus 4 root 2 over 2, or more simply, x is equal to 7 minus 2 root 2. Alright, so those are our 3 points. So let's see if we can re-sketch this with this information present to us. Alright, so let's redraw our curve. So 1 curve, 2 curve, 3 curve. And there's our area of interest. So this point we already found. So A is equal to 1. This value was equal to 10 thirds. And this value here is equal to 7 minus 2 root 2. Alright, so how can we find this area? So I'm going to break this area down into a few pieces. So notice that this area here, so if I call this green curve f of x, this purple area, which if I call a is just going to be equal to the integral from 1 to 10 thirds underneath f of x dx. So how can I find this piece here, which I'm going to call a1? So a1 is going to be the integral from 1 to 10 thirds. I'm going to call this function g of x. So if I find the area underneath g of x, that's going to be everything underneath the g, right? So it's going to be g of x, but I need to take away this piece right here. So I need to subtract from it f of x dx. So that's important. So a1 is going to be equal to the integral from 1 to 10 thirds of g of x minus f of x. And same thing is going to go for this other piece. So if I find the area underneath, let's call this function h of x. So if I find the area underneath h of x, that's going to give me everything here. But if I find the area underneath f of x on the interval 10 thirds to 7 minus 2 root 2, that's going to give me this region here. So if I take yellow and subtract that from orange, that's just going to give me that yellow region. So if I call this region here a2, so a2 is going to be equal to the integral from 10 thirds to 7 minus 2 root 2 of the function that's on top, h of x, minus the function that's on bottom, which we call it f of x. So definitely a lot of things going on here. So the decomposing area is step 2. And now we need to solve these equations and then add them together. So f of x is our line by definition. So f of x is equal to our line. So 2x minus 1. G of x equals the parabola that sweeps down. So that's going to be equal to x squared minus 12x plus 40. And h of x is going to be that other curve. Nope. This is not right. So g of x is equal to x squared and h of x is the other one. Okay, cool. So once you have everything organized, and it's not unique on how you do this, but you know, whatever works. So a1 is going to be equal to the integral from 1 to 10 thirds of g of x minus f of x. That seems to be a very friendly integral, so that's going to be equal to the integral from 1 to 10 thirds of x squared minus 2x plus 1 dx. Using the power rule, that's going to be equal to 1/3 x cubed minus x squared plus x. And then I'm going to evaluate this from 10 thirds to 1. So once you plug in 10 thirds to all of that, simplify, plug in 1 into all of that, simplify and subtract. You should find out that a1 is going to be equal to 343 divided by 81. So that's the first step. So a2 is going to be equal to the integral from 10 thirds to 7 minus 2 root 2 of, what are we subtracting? So h minus f. So h, x squared minus 12x plus 40 minus our f of x function, 2x minus 1 dx. So that's going to be equal to the integral from 10 thirds to 7 minus 2 root 2 of x squared, so minus 2x is going to be minus 4x, 40 minus minus 1 is going to be 41 dx. So that means a2 is going to be equal to, so antiderivative of x squared, 1/3 x cubed, antiderivative of minus 4x is going to be minus 2x squared, antiderivative of 41 is going to be 41x. And then you evaluate that at 7 minus 2 root 2, evaluate that at 10 thirds, subtract those values, which I'm not going to do, of course. That's going to take a lot of algebra, which I do not want to go through right now. But once you do that correctly, you should get 32 root 2 over 3 minus 1045 all over 81. So what do we have so far? So if we go back and look at our picture, so let's redraw our picture just to make it more cleaner. So we have this, we have that, we have this. So we've broken up our area into two pieces. So this is area 1 and area 2, and we're interested in the total area. So these two numbers that we have here, so a1, which came out to 343 over 81, and a2, which came out to 32 root 2 over 3 minus 1045 over 81. All we need to do is add these up, and that gives us our total area. So that means our area of interest, a1 plus a2, you should get that to be 32 root 2 over 3, since that's the rational portion, minus 26 over 3, once you combine that and that expression. And of course, if you have a calculator, you can approximate that to be equal to approximately 6.2 square units. Now I hope that is not on your exam, because there's lots of computational things that could go wrong with this. But that is pretty much the process that you need to do in order to solve these problems. So let me just quickly run them through. So step 1, find the x intersection points. Step 2, break down your areas. So break down areas into smaller parts. And then step 3, and also label functions. And then step 3, solve for all part areas. Then add. And that's the general procedure for finding the areas between curves, no matter how complicated they may be.